Tonight we have an ordered triple of positive integers. In n, the scripted n over here just means positive integers. It's sometimes called z plus or z greater than or equal to 0. It's posited that there's an ordered triple ABC such that 43 is a divisor of the quantity 6a plus 7b plus 8c. And that's what this means, is vertical bar means divides. For example, 43 would divide, 129? 3 times 43 is 129. It's just a clean way of saying, it's an operator in a sense, I guess, or just a statement, I suppose. But anyway, we've kind of parameterized things here. We've let a equal to 4 times another variable, t, which we'll call a parameter. And then b is equal to 3t plus 40. Then finally, c is just equal to t. And we're supposed to look for the largest negative value of t. Now, this might be slightly confusing, but one thing to note, though, is that also this statement here is absolutely equivalent to this statement right down here. Okay, this reads 6a plus 7b plus 8c is congruent to 0 mod 43. But what that means is that 6a plus 7b plus 8c minus 0 is a multiple of 43. So we're turning divisibility into a equation form here, which turns out to be quite useful. So let me start out with another, or let me just write down something that's important in terms of this part right here. Find the largest negative value of t. 43 trivially is congruent to 0 mod 43. I won't write this down, but modulo 43 is congruent to 0. Now you can multiply, and this is something you would know anyway, but if you multiply through by, let's call it m, okay, that implies that 43m is also congruent to 0. 43 times m is also congruent to 0. And just in everyday language, if something is a divisor, if something is divisible by something, then if you multiply it by another integer, that same thing is divisible. Okay, so 43m is congruent to 0 also mod for any integer m, right? And again, that's just like 2 divides 6, right? But 2 also divides 3 times 6, which is 18, right? It's the same kind of thing right here, except we're just putting it in equation form, all right? Now, so this equivalent form, we perform the substitutions indicated by the second statement right here. And this is just arithmetic. 6 times 4t is 24t. 7 times 3t is 21t. That's 45t plus 8t is 53t. Okay, and the rest of the arithmetic gives you 496. Okay, now we're going to use this fact that 43 times m, that should be 43 times m, is the same thing as 0. To rewrite this, notice that this is 53 is 43 plus 10, right? And so this would become 10t because 53 is 43 plus 10, but 43 is 0 mod 43. Okay. Now right here, what do we need? This would be 10 times 43 is 430. 11 times 43 is what? 473, right? So this would be plus, let me put this parenthetically, 11 times 43, right? 11 times 43 is 430 plus 43, which is 473. And so that leaves a 23 right here. All right. Okay, congruent to 0. And again, I'm omitting writing down mod 43. It's clear. All right. But remember, 43 times any integer is 0, right? So this part just goes poof right here. And you end up with 10t plus 23 is congruent to 0. Now, I guess you could solve this directly right now. You're looking for this largest negative value of t. Now, remember, minus 1 is the largest negative number, right? It's the smallest, the absolute value of negative 1 is the smallest positive integer, but minus 1 is the largest negative integer. But what I would do right here is just observe that this has the solution t equals 2. It's a little bit easier for me to think of it that way. t is equal to 2 gives us 20 plus 23, which is 43, right? So that implies that t is equal to 2, but we're looking for a negative value of t. And all we have to do is think about what is what negative number is 43 away from 2? Well, that would be negative 41, right? 2 is congruent to negative 41. For the very same reasons, you don't have to worry about the negatives too much. The difference between these two numbers on the number line is a distance of 43. So 2 is congruent to negative 41, and I'll go ahead and write mod 43. And y'all who've sat through number theory courses, you know that once you have a solution to these type of congruences, you can add any multiple of the modulus and get another solution. So there's an accountably infinite number of solutions once you find one solution. Okay, but anyway, so we'll get t is equal to 2, and this right here. This is the answer we're looking for. By the way, this 2 over here is called the least positive residue. They have a bunch of sophisticated language, but it's just the smallest positive integer solution, you know. So anyway, 2 congruent to minus 1, minus 41, 43, minus 41 is the solution. Let's write it up here. The largest negative value of t is minus 40, already forgot, minus 41. Okay, good night.